Okay, for the next lesson, we are going to be solving a system of equations by graphing. All right, so we can solve a system of equations by using the substitution method. That's what we learned about on Monday and Tuesday. But we could also do it by graphing. And again, this should be one of these where you saw it in maybe 7th and 8th grade. But 8th grade, because of the shutdown, don't know quite how much you might have seen or done with it. So let's take a look at that here today. So we have our system of equations again, where it's two or more linear equations. And then we can graph each equation to find the intersection of the lines. And where the lines intersect is going to be our solution to the system. So on this first example that we have here, I've gone ahead and graphed out two lines, okay, line 1 and line 2. And where they intersect is then the solution to the system. What we did previously was to solve this by the substitution method, and we got a location of where they of what the solution is. Here with two lines, graph out the two lines, see where they intersect, which in this case they are intersecting right here at this point 1, 2. And therefore 1, 2 is the solution to my system of equations. Now I have a follow-up question here. What quadrant or axis does the solution lie in? So let's not forget about our quadrants, because these are good questions to keep asking you. And in this case, we are lying in quadrant 1. Okay? If I could spell the word quadrant. Now, if it's not been already graphed for you, or sorry, number 2, okay, given the system equations below, determine if the following order pairs are a solution or not. So what we want now to do here is a follow-up question here. Use the point from our answer in question 1, and then see if it is a solution to yours. So what we need to do then is plug in 1 and 2 for x and y and see if both equations are true. If both equations are true, we know that that's a solution. So for that top equation, y is 2 and x is 1 from the first example. So when we work this out, we're seeing if the left is equal to the right. And when we do show that, that means so far that checks out. It is looking like to be a solution, but we got to check it for both equations. So when I do it for the other one, y is 2 and x is 1. If it's true again for both of them, then it's a solution to that system. If it fails on one of them, then it's not a solution. So what about the point 0, -3? Let's try it again, but with a different point. Y is -3. I'm going to use that top equation again. X is 0. And when I work this out, I see that right here, this is not true. This is not working there. Now, I can stop right there because I know it's not going to be a solution for the system, but just to show you, it might work on one of these. So as I plug in my second one, I can see right here, it actually works for the second equation, but does not work for the first one. It's got to work for both of them. Whoops, that is a true statement. That's got to work for both of them to be a solution to the system. And if one of them fails, it's not a solution. So that's why we said, again, 1, 2 was a solution to the system, but 0, -3 turned out not to be. And as we work through these here today, in order to be a solution, number of solutions you're going to have is one solution. That's the best we're going to get.